Hello everybody, this is a review of the X130 quadcopter kit. So let's see what comes in the kit. First, the frame. Alright, so it's a 130 millimeter quadcopter, which means it's 130 millimeters from motor center to motor center, and you can see it's in the X-frame configuration. So this is the bottom plate here. So measuring the thickness, it's 3 millimeters thick. Alright, so these components make up the top camera housing. So the side plates are 2 millimeters. One of the top mounting plates are 2 millimeters. Bottom plate, again 2 millimeters, and another mounting plate, 2 millimeters. Okay, so that's all 2 millimeters. And with the quadcopter kit, you get some aluminum standoffs, some longer ones. These are used in the camera housing, and then you have some smaller ones, smaller aluminum ones with some, looks to be 3 millimeter screws that are used to mount up your flight controller, power distribution board. You also have some nylon standoffs could be used for the same, and some more mounting screws. So we'll figure out how to use these best in a minute. Alright, now moving on to the motors, you get 4 motors. They are 1306 3100 kV motors. These are rated up to 4S. Of course, you get the counterclockwise and the clockwise versions. You have various motor mounting screws. These are 2 millimeter, and you have 2 different lengths. You have ones that are 5 millimeters long and ones that are 6.7 millimeters long. So I think they probably provided these so you can use, we would just use one size or the other size depending on how much we have coming out of the bottom of the frame. So we'll check that in a minute. So the ESCs that are provided are 20 amp BLHeli S ESCs. These are rated up to 30 amps peak. They are good for 2S to 4S. They're compatible with all the analog protocols from pulse width modulated all the way up to multi-shot, and all the digital protocols from D-Shot 150 up to D-Shot 600. So you don't have to remove any capacitors on these like you do on some ESCs to be able to make them compatible with D-Shot. You can configure these completely within BLHeli Configurator. Alright, you get a couple of battery straps, 2 different sets of props, and an XT60 connector. So to complete this build, you're going to need some sort of FPV camera. So for this, I'm going to be using a Foxeer Monster V2 camera. You'll need a video transmitter. This is just a standard 200 milliwatt output, 40 channel video transmitter. You need some sort of antenna. This is a 4-lobe cloverleaf. You'll need a flight controller. And so this is the Hobbymate F3 flight controller with OSD. This has a built-in power distribution board, so the advantage of using something like this is that you have your flight controller, power distribution board, and OSD all built into one. So that really makes for a very clean, tight build, especially in a small quadcopter like this. You also need a receiver, and so I have a Taranis, so I'll be using this FR Sky. I got this from Hobbymate as well. This has got S-Bus, PPM, or pulse width modulated output, and so it's very small, as you can see here, and it'll fit in this build nicely. Last but not least, I'll be using a 4S 1000 milliamp hour battery. So before we start assembling everything, let's see what the individual components weigh. Let's start off with the components that come in the kit. So the frame, weighs 35 for the carbon fiber components, adding standoffs, about 50 grams, deduct just a little bit for the bags and the fact that we're not probably using all the hardware. Then you have the motors, it's about another 50 grams, ESCs, about another 20 grams. Of course, we'll trim off a little bit of wires on the ESCs. You have a, let's get the battery lead next. It'll get a little bit lighter, about another 12 grams up to 132. Of course, not much for the battery strap. And then if I can get the props on here. Alright, so about 140 grams, and then we'll have just a few more grams for, probably no more than 2 grams for the motor screws. Alright, so about 140 grams or so for the components that come in the kit. And so for the extra components, I have my flight controller, weighs about 8 grams. That little receiver doesn't even weigh a gram hardly. Video TX, antenna, camera, all that weighs about 40 grams total. And the battery I'm using is about 100 and almost 114 grams. So you can kind of see by looking at all the weights, all those components added up, this is going to make for a very light build. So let's take a look and see how these components might fit together. So I've got the some of the hardware unbagged, and I've started by using some of the longer of the 2 screws to start mounting some of these nylon standoffs. So in the small aluminum standoff bag, you'll have some longer screws, and these are the same diameter but slightly shorter. In order to get through the thickness of this bottom plate, you'll need to use the longer ones. So I've got those with the nylon standoffs. So start to mount my flight controller. So you'll notice a couple slots here in the bottom plate. That's where your battery strap could go through if you wanted to, or you could just run it all the way across. That's what I usually do. So if I put my flight controller on there, so kind of take a look at some of the connections on the flight controller. So you have your motor power out to your ESCs, and your battery lead will connect up to these positive and negative pads on either side. The signal wires out to your ESCs, you don't need ground, you just need just be the white lead, and you connect that up to these pads here. That's for motor 1 and 2 and 3 and 4. This board has 3 amp output for both 5 volts and 12 volts. So you hook up your camera and your VTX, whichever voltage you want for those to those. So for your camera in, because it has OSD, that you would connect it up to this. That would be for the camera in, the video in. Yellow wire from your camera typically would go to here, and then yellow wire out to your VTX would go here. In order to flash it with BetaFlight, we'll bridge these little pads here on this boot pin, and we'll do that in order to be able to flash BetaFlight. And then one more thing, on the back side of the board, there is some little pads here that you need to bridge, whether you're using for the OSD, whether you're using PAL, or you're using NTSC. I'll be using PAL on this, so I will be bridging the pads, and they're right here. Okay, so kind of moving on to getting everything kind of dry fit together here. So go down with the flight controller board. Now if you had a power distribution board, that would be on the bottom typically, and then your flight controller board on top, and Hobbymate gives you enough standoffs to be able to do that, but I won't need those extra ones there. So then I'll go to these aluminum standoffs. And then you have the bottom board here that'll mount like that. And then you can use some of the shorter screws to mount that one. Grab my Allen wrench. Just put a couple of those in there for now. See, I did one thing you do have to watch here. I got this sideways. You want these little tabs to be to the sides, because that's how the top mounting plate moves on, connects on there. So I'll go ahead and put this together and I'll be right back. Alright, so I've got the top mounting plate assembled. In the screws you get 6 of the long ones and 4 of the short ones. So I use 4 of the long ones here in the bottom, and then 4 short ones here on around there. I use the short ones in the bottom, and I use long ones in the top of the camera frame. And the reason I did that is because, you know, your camera's going to fit in here snug, so you use a little bit longer screws, you can spread it out a little bit farther. You'll be loosening the bottom ones less. So if we kind of look and see how this might go together. So camera would go in something like that. You'll notice on this kit there are holes here on the side of these side plates that you mount your camera mounting screws through. And if you have the kind of camera that has the extra little bracket and back where you can adjust the angle, you can put that screw in there. So there's the camera, Video TX. That'll work out good. Put a little bit of double-sided sticky tape on the back of the Video TX there, just a little bit, because that's the side that all the heat is dissipated. Do something like that. We'll be putting the battery lead in here, and maybe running the wire down like this or keeping it short. We'll see what seems to make sense on that. Let me go ahead and let's take a look at the motors. So remember, we got those 2 different size screws, the ones that are 5 millimeters long and the ones that are 6.7 millimeters long. I took a look at it. I think the 5 millimeter ones are the right ones to use. They just come up through the bottom there just enough to grab all the threads on the bottom of the motor. If you had some sort of, if you wanted to soft mount your motors with a little bit of foam tape or something, seems popular nowadays, then you might be able to use the longer screws. It's nice that they provide both. So I'll go ahead and get a couple motors on here, and we'll see how these ESCs will fit. Alright, so I've got a couple of the motors mounted. The 5 millimeter long screws are the right ones to use. So I think we have a couple different options for mounting the ESCs. These 20 amp ESCs are small enough where they can be mounted up on top here. And so sometimes I trim the motor leads back, but I don't think I will here in this case. I think I have enough room just to solder the individual motor leads on, kind of going this back way here, and then maybe covering them up with either a piece of heat shrink like this, or maybe even some electrical tape. as an alternative, these frames have a slot in the end which you can mount the motors with the wires facing out, and then you could mount your ESCs on the bottom like this, and then run your wires up top. I think, you know, if you are using this frame with different ESCs that are a little bit bigger, that might be an option. But I think with these Hobbymate ones, I think it's fine just to mount them up top, and makes for a little neater build. There's no wires on the bottom, but then you can run the power leads over to the flight controller or the power distribution board, and your signal wires in as well. So that's how I'm gonna proceed. So I'll go ahead and we'll be thinking about the rest of the components. You know, one other thing that I think we can do here, if you on your receiver, I've seen people mount it outside. On a X160 build, I actually mounted it on this back plate in here and ran the antenna out a little hole here. So with this one, that's what I'm going to do. I'm going to mount it on this back plate and run the antenna up to this little hole. And so, but I think you got a lot of different options, and obviously when you run wires in this up from the for the video TX and your camera, you can run them down up through this hole in this bottom plate here. So we'll start. I'll start go ahead and getting everything laid out to ready to start soldering up these motors to these ESCs, and we'll take it from there. Alright, so let's prepare these motor wires and solder pads on the ESCs for soldering. So what I'm doing here is I'm using some flux and just putting a light coat on all the surfaces I'm going to be soldering. Flux is great. I highly suggest using it. It makes for a lot cleaner soldering, and the solder just works a lot better. So we'll just tin these motor leads here. These motor leads are nice silicone wire, so they don't shrink when you put solder on them. They don't shrink back. All right, so there's a motor lead. Tin these ESC pads real quick. Alright. You can trim these motor wires just a hair back after we trim them. We don't need much for soldering. Something about like that. So it doesn't matter which order you want to put these on, just whatever's neatest. But I'm going to solder them pretty close up to the... There we go. And now the middle one. One. There we go. All right. Pretty simple. All right, so now we'll get that back on the frame and see if that works out good or not. All right, so I've got the motor mounted, and I think it worked out pretty good. You can see here that that I just ran the motor wires down along the side, folded them back on the ESC here, and I'll just I'll probably end up putting a piece of electrical tape or heat shrink over here to protect these pads here, because you don't want these pads to touch off on the motor housing, or you don't want to rub, and you don't want it to conduct any, make a short between the pads and the frame. So but you got plenty of room here. You can see I can pull it back pretty far, probably something about like that, and maybe use a piece of double-sided sticky tape on the bottom of the ESCs to make sure they don't move around, or if you use electrical tape, obviously it won't move around at all either. So I think that'll work out good. So what I'm gonna do now is go ahead and solder up the rest of those ESCs and motors, and we'll start seeing how the flight control wiring looks. Alright, so I've got all the ESCs mounted. You can see here I've got plenty of clearance in order to keep away from the motor. I'll go ahead, and this is just temporary electrical tape, just kind of hold things in place while I'll do the soldering. But when I clean it up at the end, I'll put electrical tape over those pads, and probably a little electrical tape on the bottom too, in order to make sure nothing shorts out on the bottom side. One thing I did change when I was looking at mounting this flight controller to this board, it's got some connectors on the bottom here, and be running the battery strap through here. I wanted a little bit more clearance, so these little short, the shorter red standoffs are longer than the nylon standoffs, which had the nylon on the bottom to begin with. So I just swapped them around and gave them a little bit more room underneath, so and make clearance. So if you do the same thing, one thing I also wanted to kind of check is, these top board components, like this connector here that's used to hook up, you just want to make sure you have enough clearance here in order that it doesn't hit it, and so I'm good here. So with that, so up next I'll be running the ESC power leads up to the main pads, and getting the battery connector on, and then also running the ESC signal leads to the individual pads for those also. But one thing I want to do before I do all that is I do want to flash this with BetaFlight. So I need to take this ESC back off and bridge those little pads, and I also need to bridge a boot pad, and I also need to bridge the PAL pad on the back side, since I'll be using PAL on the LSD. So I'll go ahead and do that. Alright, I'm about halfway done wiring up the ESCs, and I wanted to show you how it's coming along. Alright, so when I wire these up, I always try to think about the cleanest way to do it, and I go slow. This takes me longer than any other part of the build. So what I'll do is I will figure out one wire, the best way to route it, and then I will cut that wire, and I will solder that wire, and then I'll move to the next one. Now I'll typically try to keep it clean here from side to side. So this is the front of the quad going this way, and so I'll try to keep it clean side to side. And that way, because the battery strap is going to be coming through here, so I'll have all my wires. This is actually the front of the quad, but I'll have all my wires on either the front or the back. And so then I always try to keep, and because realize that we have little wires for the ESCs, signal and ground, and then the bigger wires for the power for the ESCs. So I'll try to put the bigger wires, the thicker wires, on the outside, because they have a tendency to hold the smaller wires in, and they stay there pretty good. So also you'll see here I have the 12-volt power leads that I'll run up. This will be for my camera and my VTX. That'll run up through the stack, through that little hole, and provide power for those. And you can see over here, I've already tinned the pads. So I always pre-tin them so they're ready to go. I always trim the wires, flux, tin, and then I solder them. All right, so I'll get the rest of these wired up, and I'll be right back. Okay, I got everything just about wired up to the flight controller. You can see I finished this other side here. You know, one thing you got to kind of think about is when you wire these things up, you might have to get to some connectors on the bottom of these. If you're using one of these all-in-one type of power distribution board and flight controllers, you might have to get to some of these little connectors down here. So you got to think about that. So if they were on this side, I would have had to route around them, but I did have to route around them on the back side here, because I have to get to this one in order to hook up the S-bus receiver. So think about that before you route your wires. So that, you know, I decided to run some of the wires over the top here instead of blocking, you know, otherwise I would have blocked some of those ports. So decided a short battery lead was kind of best here. So it'll just go like this. It'll stay out of the props. You know, when they're that short and they've got, you know, essentially the wire fills with solder and it gets pretty stiff. So I think that'll work out fine. So here is the S-bus receiver that I'm using. This is the little Hobbymate. I've got the leads on it long now, and that's where that plugs in. But I've got the leads on it long now. Now, once I figure out exactly how long they need to be, I'll just trim them up and shorten them up and solder them back to the flight control. I'm sorry, to the receiver. And that's the other one that goes with the flight controller that I won't end up needing. So you know, you might notice a couple other wires. So, you know, again, we talked about this already. This is my 12 volts going up to my camera and my VTX, and this is the buzzer. So obviously I don't need that long. Again, I'll trim it. So you know, I think it's coming along great. I'm happy with it. Get to the USB port easy on the side here. If you had Spectrum, you'd just be plugging into this port here. You know, I think it's looking really neat. So I'm pretty excited about this. So next I'll start building up the stack up and start bringing the wires up through there and start wiring up the camera and the VTX and figuring out the right length for the receiver. All right, till then. All right, so I've got the bottom plate of the camera housing installed now, and I want to show you what I was planning on doing. So I decided to go ahead and run different connectors for one for 5 volts and one for 12 volts, along with, this is for my receiver, and this is going to be for my buzzer, and this is going to be a battery, a voltage lead for the OSD in my camera. So so what I'm going to do here is try out 2 different cameras. You know, first I'm going to use a standard, as I was saying earlier, a standard sized video camera with the standard VTX. So I'll use the 12 volt supply for that. But then I thought, all right, so now I'll use, as part of an ultralight build, I'll try out this Hobbymate camera, and this has this is either 25 milliwatt output or selectable to 200 milliwatt output, and also is selectable between PAL and NTSC. So I'll use that as part of an ultralight build, and I don't know if you noticed a second ago, but I have also installed an XT30 connector in parallel to the XT60 connector. And so what that's going to allow me to do, and that's just kind of for the experiment, that's going to allow me to use the standard battery with the XT60. Again, this is a 4S 1000 pack, and use that for the standard, and then switched for the ultralight build, and this will be along with this small camera. I'll go to a 4-cell 450. Of course, it's got an XT30 connector. So this will allow me this is an easy way for me to try both of them without taking everything back apart. So so with that, we'll go ahead and continue, and I'll go ahead and put the full-size camera in there first. Alright, so I've got all the FPV equipment wired up, and I want to show it to you before I put the camera in, because I think once I put the other side plate on, it's going to be hard to see. So I took that little Hobbymate FR Sky receiver and I put on the just double-sided sticky taped it on the back of this inside plate here. And so it's a little hole that they have in the top plate here that antenna goes up through really nicely. So I've got this will be going to my camera. This is a pigtail from the OSD off my camera, and this is the 5-volt lead that I'll use when I try out that little micro camera. So I think it's ready to go. Oh, the other thing is I went ahead, I thought I was going to try to find a place for the buzzer up top here, but I didn't find a good spot, so I just went ahead and mounted up front here and just secured it with a little hot glue. So hopefully that'll hold. And so now I'll go ahead and put the camera in, and that'll about wrap it up. Okay, I'm done putting the top housing together. Camera fits in there nice and snug. Put the VTX here on the back. I got a couple real thin strips of double-sided sticky tape holding it on to this back plate here. You don't want to put much on there because that's the side of the video transmitter where the heat's dissipated. Got the wires running under here into the camera housing area. I think it looks great. Really think it looks like a clean build. So next up we will go over to the computer, configure BetaFlight, and configure the ESCs with BLHeli Suite.
Alright, so I've got my quadcopter here, I've got a battery, and I've got my transmitter, and on my quadcopter I do not have any props. So let's get BetaFlight first. Alright, so if you just type in BetaFlight to Google Chrome, and then BetaFlight is a Chrome app, so you click on this, pulls it up. If you didn't have it installed, it would say install app here. I've already got it installed, so what I'm going to do is plug in my quadcopter to the USB port. No battery yet. All right. So if you've never plugged in your flight controller to the USB, then it would install the drivers now, and it would come up to a COM port. And so when you click Launch App, you would have an option of which COM port to select, and it automatically comes up to the default one, whichever one yours is set up to. So on mine, it's COM 3. If you had not flashed firmware on your flight controller yet, you would not hit connect, but you would go down here to hit flash firmware, and you would select the type of board you have. This happens to be an SP Racing F3 Target, and you would select the latest firmware. Seems like manual baud rate set to 115/200 works for most boards. That's how I usually have it. Keep that selected for that all the time. So with that, you would hit load firmware online, and then you would flash firmware. Now, sometimes on some boards you have to short the bootloader pins or press a bootloader button. So if it doesn't work the first time, after you hit flash firmware, if it says it cannot contact bootloader, then you would press that button or short those pins and try it again. So I don't need to do that because I've already got it updated to the latest version. So I'll go back over here and just hit connect. And one of the first things you can do is just see what version you're on, and type in version there, and then as I said, this is the latest version at the time of this video, 3.1.7. And then the other thing that's always good to do when you first start off is to type dump in the CLI command and capture all of this information, right click on it, hit copy, and paste it into Notepad or some other text editor and save that file. That way you have a backup of all your stock settings. All right, so I'll go back over to setup here. So you know your quadcopter is connected because if you move around your quad while it's connected to USB, you see it moving within BetaFlight. So here, if you have your quadcopter at level service, you can go ahead and hit calibrate accelerometer. You can see it kind of levels it up. One of the things I like to do is turn on expert mode up here in the upper right hand corner, and you get all the tabs. So I've already set this up, so I'll show you how it's set up, and then we'll go through each tab. So you typically need to set up your receiver on one of the UARTs. I have mine connected up to UART 3. If it's a serial receiver, you wanna click this. If it's like an S-bus type receiver or a Spectrum receiver, those are both serial receivers. So you want to check this right here, save and reboot every time you make a change. Otherwise, you lose. It doesn't save the changes. So next tab is configuration. All right, so with these Hobbymate 20 amp ESCs, like I was saying during the build, they're compatible with all of these protocols, well, except for brushed, of course. That's for brushed motors. But pulse width modulated. These three are here, the analog protocols. These three here are the digital protocols. The ones farthest down the list are the highest speed protocols. So multi-shot's the highest speed analog, and D-Shot 600 is the highest speed digital. So if your flight controller is an F3 or F4 based flight controller, then likely you can utilize the fastest protocols, which is like a D-Shot 600. I don't think it's listed here unless it is compatible. Mine is, it's my F3 flight controller, so it is listed. So I typically like to have motor stop enabled. I don't like it to spin as soon as I arm it, and then I like to have it. I like to be able to flip uh, the switch, the arm disarm switch, and stop the motors at independent of the throttle value. So going down through here on the left side here, as we talked about receiver, I've got my serial based receiver. So this is one you have selected for Spectrum satellites or S-bus. If you were doing PPM receiver, then you would select this one. If you're doing pulse width modulated with that has a bunch of wires to it, then you would select that one. But I'm doing S-bus, and you would select that here. Oh, I'm sorry, it's going to be a serial-based receiver, but then you select what type of serial-based receiver here. If you're doing Spectrum, 1024 or 2048, you would use one of these. If you are using Spectrum and you have the wrong one of these selected, when you go over to the receiver tab, the channels don't come through correctly. It looks weird. Then just come back here and switch it, hit save and reboot, and that usually fixes the problem. But I am using a Tyrannus, so I'm using S-bus. I got RSSI on. I've got my system gyro update frequency at 4 kilohertz and the PID loop frequency set at 2 kilohertz. You can see that's about right because you see your CPU load down here is in the 20s, and you don't want it to be much higher than 30, 35 here, so this is fine. And that's for the most part it. I'm measuring battery voltage here. You don't see anything right now because I don't have the battery plugged in, but we will when I plug the battery in. All right, moving on to failsafe. I've got failsafe enabled. It's set to drop. I don't like it to try to land. That means it continues to spin motors too long, in my opinion. So I just got it set to drop. If you make any changes, you have to save and reboot, but I didn't. These are the stock PIDs. They work pretty good. Obviously, there's always room for improvement, but you get that after a little experience flying. All right, on receiver. So what I need to do here, again, props off. Turn on my transmitter. Now I'll plug in a battery to the quad. Now, if you have Spectrum, you don't have to plug in a battery because it's usually powered off the board. And so now I got a battery plugged in. And what you want to do is make sure that the channel map looks right. So, there's my ailerons, and so that should be roll. There's my elevator, so that should be pitch. I've got the yaw here, which is on the rudder, and then throttle here. Now, if it's wrong, you can change the channel order over here. You just type it in the right order. So this is the right one for Tyrannus. So the other thing you want to do here, so there's my aileron. So you can see at the midpoint here, it's at 1500. And so when I go all the way to the left, you want it to be close to 1000, and all the way to the right, you want it to be around 2000. It doesn't have to be exact, but pretty close. But in the midpoint, it should be really close to 1500. So if it's not, you need to adjust your sub trims within your radio so that you get 1500 in the midpoints for all your channels. And then your channel throws, you want to increase those so that you get close to 2000 on the top end, and and then 1000 on the bottom end. And I do that for pitch, roll, yaw, and throttle. And I don't worry about it for the aux channels. Uh, it's not as important for those, but I do that for the main four. So you kind of see, you got to, what's good to note here is you note which one's moving. So this is a two-way switch because we're going to be configuring these in the modes tab in a second. And then you have, this is a three-way switch, my aux 2, and then my aux 3 is actually a three-way switch as well. And so those are the ones I have configured on my radio. So now we'll go over to the modes tab and we'll configure them. So here, so what you want to pay attention to, so I want to configure arming by switch. So I'm going to use switch 1 or aux 1, which is my two-way switch to either arm it and disarm it. You can see it lights up and you can hear my beeper beeping when I arm it. And so you just select whichever aux channel you want from the drop-down list. So for my flight modes, I'm going to be using my three-way switch. So I'll be starting off at angle. Of course, that's the most level stabilized mode. And then this is on aux 2, three-way switch. And then I'll switch to horizon, which is kind of between angle and acro. And then if you don't have either angle or horizon selected, by default that's acro. And then the next choice you have is whether or not you want to spin props all the time in acro, and that's called air mode. And so I do want to do that in acro, and that's the reason I have that selected on. So you just move these little bars to wherever you want to make sure that they're capturing where your radio tick is landing. So the very last one I configure is the beeper, and so I use my aux 3 for that, and you can hear it. And so if I lose the quad in high grass and I'm trying to find it, I'll flip that switch and that'll help out. So from there, then I really don't need to do anything on the adjustments or servo tabs, but I will go down to motors. All right, so here on the motors tab, we're going to be testing the direction of each motor, and we're going to be referring to this little diagram up here. So numbers 1 and number 4 are supposed to be spinning the same direction, and they're supposed to be spinning clockwise. And motors number 2 and number 3 are supposed to be spinning counterclockwise. So what we'll do is we'll test the direction of each motor to see which way it's spinning and whether or not we need to reverse it within BLHeli Configurator. So no props on for this. And so you're checking this little box here. There's this kind of a safety step they have inside the software. So click that on and we'll test each motor. So 1 is supposed to be spinning clockwise. Let's see which way it's spinning. Spinning just barely, doesn't take much. And it's spinning the wrong direction. So we need to change that one. 2, it's spinning the correct direction. 3, correct direction. 4, incorrect direction. So we've got to reverse 1 and 4 within BLHeli Configurator. So that's all we have to do within BetaFlight. So I'll disconnect out of here and we'll go get BLHeli Configurator. So within Google, we'll type in BLHeli Configurator, and just like BetaFlight, it's a Chrome app. Just like BetaFlight, if you do not have it installed, it'll say install app. I've already got it installed, so it's just launch app. So it looks very similar type of layout. So again, your comm channel, we are disconnected from BetaFlight now. So we're connecting within BLHeli Configurator. It's connected. You hit read setup, and it reads all of the ESC settings. So over here on the left, this box over here is all the common parameters. So we made a change here, and then we would hit write setup. Then it would write all of those common perimeter changes at once. So we don't need to change anything here. This is all fine by default. So we see each one of our 4 ESCs over here. So we remember we were going to change ESCs 1 and 4 directions. So that's the most common thing you do. And so they have that drop-down box here, the very first thing, and easy to get to. And so that's really the only thing we need to change. But the other thing we can kind of check while we're here is take a look at the firmware. So you can use this tool to update the firmware on your ESCs. So this right here is the firmware name of the that's on each ESC. So it's C-H-20. and it's firmware version 16.6. So if you hit flash firmware here, there's our ESC. So you don't want to change that. If you flash a ESC with the wrong firmware, you can brick it. So we would select our version. You know, we got version 16.6 currently, so that's really, you know, maybe 16.65 is even just a hair slightly more current, but it's got a really current firmware on here, so we don't need to change it. But if we did, we could select that when we would hit flash firmware and it would flash it. But I don't think we need to on this because it's really current anyway. So I'm gonna hit cancel here. So that's how you would flash firmware down the road if a new firmware version came out and that you wanted to flash. Anyway, so we're just gonna switch reverse channels 1 and 4. So all you have to do is select reverse, hit right setup, and that's it. And you can hit reset just to make sure it doesn't change back to normal here. It's staying reverse, so that's an indication that it's all good. So that's all you got to do. It's really simple. They've really taken this BLHeli configurator software and made it really simple. So now that's really it. So we've done everything. It's ready for a maiden, so I'll go ahead and put props on, and we'll get ready to take it for a flight.
All right, so here we are, ready for the maiden. This thing looks great. Really happy with it. Got a little zip tie here, a little heat shrink over it for the antenna, camera. Everything looks great. So let's see what it weighs. So no battery, 175 grams. Okay, with the full size 1000 milliamp hour battery, 288. With the 450 4S battery, 230, so under 250 grams. All right, so that's incredibly lightweight. What I'm going to do here is I'm going to fly it first with the full-size camera in it, and then I'm going to come back and I'm going to fly it with, well, first of all, I'm going to fly it with full-size camera and both batteries, and then I'll come back and I'll take out the camera and the FPV transmitter and the antenna, and I'll swap out to this. So that's going to cut some even more weight off this. So this will be, maybe I'll characterize it as the ultralight build, and I'll just use this battery. So that'll be the ultralight. So that's going to shave even more grams off of that. We'll see where that comes out as. So kind of size comparison here. I've got the X160 here also. So you get an idea on the size difference here between the two quads. So the top camera housing is the same. This stack up is higher because this one I use a power distribution board and a flight controller, whereas on this one the flight controller and power distribution board are all in one. So that's the difference. And kind of weight wise, remember this one, you know, this was 175 and this one's 255. So what is that? 80 grams more. And so, you know, so difference is bigger motors, one thing, and the frame slightly bigger. And of course, again, power distribution board in this one, where don't really have one in this one. So that's where we are. So let's go down and take this for a test flight and see how it does. I've got some pretty high expectations of how this is going to work. All right, we'll see you down there. All right, so here we are for the maiden of the Hobbymate X130. It's a little windy today. Hopefully the wind noise won't come over the mic too bad. But I've got the 4S 1000 battery on here, so let's see how she does. All right, so far so good. See how she feels. About like her bigger brother, the 160 millimeter.
like the sound it makes. Let's try a little punch out test. Alright, pretty good. You know, it's very nimble. Do another punch out test. Yeah, that does pretty good. I wonder if it's going to do any better with that slightly smaller battery on it. Lighter battery, really. Alright, well, let's give that other battery a try. Alright, so this is the 4S 450. Let's give it a try. See it leaning into the wind there? You know, I do think you can feel that it's lighter. I mean, this battery weighs, I think, about half the weight as that other one. Alright, let's try the punch out. Yeah, I think it has more punch out with a lighter battery. I mean, that makes sense. It sure takes off like a rocket. And it wants to float too. I think I might prefer this size battery, the smaller battery, over the larger one. Let's see what kind of runtime we get out of it. All right. Let's go ahead and land here. Fighting that wind a little bit. All right, there we go. Alright, so I just landed after that acro flight. Just wanted to see if the motors were hot. Not at all. They're cool to the touch. Speed controls, of course, are cool to the touch too. So, alright, all good for that test. Alright, I guess we'll go ahead and try the smaller camera, and again with the smaller battery, and we'll see. You know, expect a little bit even better performance than we got already. But I'm already super impressed with this. You know, it really flies like a 5-inch quad, and you don't really realize that it's just a 3-inch quad in the air. It really feels like a 5-inch with the punch out and the power it has, and you wouldn't know from inside the goggles. But all right, well, we'll try the even smaller camera, so expect even even better performance than we've already got. It's hard to believe, but all right, see ya.
Now I've taken out the full-size camera and the antenna and the VTX, and I put in the Hobbymate Micro Camera. So this has got 25 milliwatt selectable to 200 milliwatt output. It's selectable between NTSC and PAL. And so all I did to mount it was put a little piece of double-sided sticky tape on the bottom here, a little one back here against the antenna, and put a little rubber band to hold it in there. And it's in there really secure. So I've got the 5 volts to supply the camera off the flight controller. And so that's all there's to it. So let's see what this weighs now. So remember before we had with the other setup, it was 175 grams. So now with this, that was without battery, now it's 148. So that is cut, 27 grams off of that. And so if I add this small battery, we're just at 200 grams. So that's probably going to make a pretty big difference. So let's get down the flying field and let's try this one out. Also with this camera, Hobbymate supplies a little power splitter and some double-sided foam tape. So that's nice. All right, let's go down the field.
So here we are with the micro camera and the 4S450. All right, let's get out here a little bit and do a punch out. Yeah, I say that, every gram counts in these. So less weight, same power. All right. Let's do a little FPV.